Good evening, my dear students. I am Justin. I am your new science faculty, and I am going to teach you the third chapter, which is atoms and molecules. Before we start our studies or today's class, let us have a small thought or a good thought. The thought is a small story about sharpening weapons. There were two woodcutters in a village. Both were friends, and the first woodcutter will go early in the morning to the forest and work till the evening, and he will fell 10 trees. On the other hand, his friend, he also starts in the morning and he will fall 20 trees by afternoon. And the first woodcutter was little bit disappointed. He is thinking the second woodcutter is felling more trees than me. He is coming early in the morning and he is going by afternoon. And the first woodcutter is working till evening. What is the secret? Some secret or some tricks will be there. Let me see what he is doing. So the first woodcutter hid behind one bush, and in order to find what the second woodcutter is doing. And the first woodcutter observed that after every tree have been fall down, the second woodcutter will sharpen his tool, which is the axe. He will sharpen the axe and he will fall the next tree. After that, he will sharpen and make it sharp, and again he will do the same, and he will finish his work by afternoon. And he finally go back to his home. So, in our today's life, we should use this time thinking that this is a time to sharpen our qualities or sharpen our mind, and we have to achieve success. So, sharpen your brain, sharpen your thoughts, and achieve success. And I'm going directly towards the third chapter, which is atoms and molecules. Chapter 3, Atoms and Molecules. Here also we have a little bit story that means related to chemistry. Okay, let us go to the ancient times. We will first see what happened in the ancient times. And in ancient time, it all happens. And the ancient Indians and ancient Greeks philosopher made philosophical studies, not experimental. They made philosophical studies on unseen form of matter. On the unseen form of matter, the philosophers of ancient Greece and ancient Indians made studies. Okay, and we can proudly say that it all started in India. And I will mention some name. I will introduce some names to you. One is Kanad Maharshi. Kanad Maharshi. Okay, he is one of the philosophers from India. And this Maharshi stated that when we go further dividing the matter, that means in substance, we are going further dividing that means he said any padartha is going to divide more. Finally, we will reach a state when it cannot be divided further. And he called it as Paramanu. Okay. And One another person, Phaguda Katyadma. Phaguda Katyadma, another philosopher, elaborated this and said, these particles normally exist in a combined form. Okay, this Maharshi said, we will reach a state when it cannot be divided further, and he called it as Paramanu. And the second philosopher elaborated this one and said this particle normally exists in a combined form. Okay, some combination is there. Okay, and he says that it gives a different form of matter. And after some time, in the same era only, the Greek philosopher, that is Democritus and Luciferus. Did you heard the name? Democritus and Luciferus. In their language, or according to their philosophy, they also said something. Let us see. Let us have a look at that. Both suggested that if we go further on dividing, we will reach a stage when the substance cannot be divided further. Okay, and Democritus named it as atoms. Okay, means invisible. The meaning of atoms is invisible. Who named that? Democritus. So, while we are talking about ancient times, and keep in mind it was based on philosophical consideration only. Up to 18th century, no any experimental work was validated. Till 18th century, no any experimental work was validated. Then what happened? In 18th century, scientists recognized difference between elements and compounds. In 18th century, scientists recognized the difference between elements and compounds. And naturally, they become interested in finding out how and why elements combine and what happens when they combine. Okay. Scientists recognized in the 18th century the difference between elements and compounds, and naturally became interested in finding how and why elements combine and what happens when they combine. Okay, till here, is it clear? And I'm going to introduce to you another name, that is Antonio L. Lavoisier. Antonio L. Lavoisier. Okay, what is his contribution? Let us check. Antonio L. Lavoisier laid the foundation of chemical sciences by establishing two important laws of chemical combination. He made two important laws of chemical combination. And let us check. One another person is also there. Joseph I. Proust. Joseph I. Proust. Okay. What is his role? Joseph I. Proust also joined in this experiment. And which experiment? To get the laws of chemical combination, he joined with Antonio L. Lavoisier. and we will check the laws. Then after doing many experiment, Antonio L. Lavoisier and Joseph I. Proust established two laws of chemical combination. Okay, Antonio L. Lavoisier and Joseph I. Proust established two laws of chemical combination. Which are they? Law of conservation of mass. One is law of conservation of mass, and second one, law of constant proportion or proportions. Okay, two laws of conservation of mass and laws of constant proportion. And now let us study law of conservation of mass. Law of conservation of mass. Let us think. Is there any change in the mass when a chemical change takes place? Is there any change in the mass when chemical change takes place? There is activity 3.1. We are just going through that activity, and after this activity we will observe is there any change. We will give the answer for this. Is there any change in mass when a chemical change take place? That we will say, we will answer there. Okay, and the activities is all about take the following set X and Y. Okay, in X there is copper sulfate, barium chloride, lead nitrate, sodium carbonate, sodium sulfate, sodium chloride. So, and first suggestion, separate a 5% solution of any one pair of substance listed in X and Y. Okay, from X I taken barium chloride, and from Y I taken, from X I taken barium chloride from X, and from Y I taken sodium sulfate. From Y I taken sodium sulfate. And next what we have to do? Take a little amount of solution of Y in a conical flask. In a conical flask, we want to take any one solution. Okay, I am taking sodium sulfate in conical flask, and some solution of X in a ignition tube. Ignition tube. So I am taking barium chloride in ignition tube. Hang the ignition tube in the flask carefully. That means we have to tie the ignition tube and we have to carefully keep inside the conical flask. We should be too much careful because it should not be mixed in the flask. Okay. Then with carefully we have to weigh the conical flask. Okay. Now tilt and swirl the flask so that both the solution will get mixed. Okay. We have to tilt and swirl the conical flask. What happened? The solution will get mixed. Then once again weight the conical flask. We are going to once again weigh the conical flask. What happens in the reaction flask? Reaction occurs because two solutions are adding. Some reaction will occur. Do you think a chemical reaction take place? Barium chloride and sodium sulfate is adding. So a chemical reaction takes place. Why should we put a cork on the mouth of the flask? Why we are putting, I forget to tell you, we have to carefully, we have to put one cork on the top of the flask after inserting the ignition tube. After inserting, we have to close the conical flask. So why we have to do so? Because already we know that if both solution are adding, a chemical reactions happen. Sometimes there will be in a chemical reactions, we know that evolution of gases may occur. So if the gas which evoluted in the chemical reaction is escaping through the opening of conical flask, it will affect the weight. So we have to cover it with a cork. Okay, so then we have to observe, does the mass inside the conical flask change? We have weighted it twice, before the reaction and after the reaction. What we can observe? Before the reaction and after the reaction, it is same. Before the reaction and after the reaction, it is same. Then from this we are going to answer, is there a change in mass when a chemical change take place? Is there any change in mass when a chemical change take place? So we can say we have weighted before the chemical reaction and also after the chemical reaction we have weighted, the weight is same. So we can say that there is no change in mass when a when a chemical reaction take place. There is no change in mass when a chemical reaction take place. Then law of conservation of mass. Law of conservation of mass state that mass can neither be created nor be destroyed in a chemical reaction. Law of conservation of mass state that mass can neither be created or nor be destroyed in a chemical reaction. And today I am going to end our today's portion, and I will be back tomorrow with more energy and to see you all. Thank you.